Okay, what I would like for you to do is take out a different color than what you used on this particular entrance slip. We're going to look at this entrance slip, and I want you to make corrections in the different color on it. I would imagine that you're probably going to have corrections, because when I looked at my first period's class of this, almost every single person did not have the first one exactly correct. Okay? Now, something I want to show to you folks, you're going to need this sometime with your molecular model kits, okay, the lab you're working on. So remember this, all right? Sulfur has 6 valence electrons, as does oxygen. So when I'm looking at this and I'm putting these valence electrons in here, I'm going to signify sulfurs as in red here. I'm going to leave that left oxygen black, and I'm going to put this oxygen as green, just so we can see whose valence electrons are where. Okay? So I can see that right here I have a double bond. Right here is, remember I called that a coordinate covalent bond. I said that sulfur is nice enough to let oxygen use 2 of its electrons. So it's sharing 2 of its electrons with oxygen, but it's not getting anything back. That's just so the whole group is stable. Now, when I'm doing my ACTS method, we need to remember that we're only dealing with the central atom. So, as I circle my central atom here, and I go A, X, E, and I look and I say, okay, how many bonded domains do I have? Well, I have 1 right here. I have 2 right here. So my X is 2. How many non-bonded domains do I have? Right there is 1. So I am looking, my shape is going to be AX2 E1. I go back to my ACTS packet and I find AX2 E1, and that shape is bent, correct? Now remember, we had 2 different types of bent. One bent had 2 unshared pair, one bent had 1 unshared pair. So this is the bent that has 1 unshared pair. So when I need to do my perspective drawing, I need to go back and find the bent that has 1 unshared pair. And when I do that, it shows me that my central atom is going to be S. On the same plane, I have my unshared pair, and then I have my 2 shared pair. Now, I'm going to say that a lot of you folks wrote it like this. This is why people missed it. Even though this guy right here is 1 domain, it's still a double bond. So we have to signify that that is a double bond. A lot of people didn't have that in my first period. Now, the final thing that I want to do is I want to make sure that I have my different, unshared pair of electrons on my oxygens. And I did this one in black, so it's only got 2 unshared pair. So right there is my correct perspective drawing for this particular Lewis dot structure. Any questions for me on that? Did you miss the double bond? Only have the one line there? Okay, I figured probably a lot of people had that. Now my second one here is dealing with chlorine and fluorine. Now I want to point something out to you right here, that when I draw a circle around this chlorine here, can you see that I have way more, well not way more, but I have more than 8 electrons around that chlorine? If I count, here's 2, here's 2, here's 2, here's 2, here's 2. 2, 4, 6, 8, 10. What this is, folks, is this is an example of what we call expanded valence. Okay? I'm not so concerned that you know how the expanded valence works, that you just know that it can expand valence. Okay? We do see that at some times. So when I do my axe method, once again, I'm going to circle my middle, my center atom, and I'm going to go A, I'm going to go X, I'm going to go E, and I look. My X is my bonding pair. I have 1, 2, 3 bonding pair. So X is 3, and I come up and I say, okay, what about my non-bonding domains? I have 1, I have 2. So I have 2 non-bonding domains. I come back to my X packet, and I'm looking for A, X3, E2. A, X3, E2. And what it tells me is that I am dealing with T-shaped. Correct? Now, I turn a couple forward now. I need to find my perspective drawing for T-shaped. There I have it. So I am going to look. I'm dealing with all single bonds and unshared pairs. See my T-shaped. It's going to give me chlorine in the middle. It's going to give me dashes to this unshared pair. It's going to give me a wedge to this unshared pair. And then it's going to give me 3 fluorines on the same plane. Now all I need to do then is to fill in my unshared pair around all of my fluorines. And ladies and gentlemen, there is my T-shaped perspective drawing of chlorine trifluoride. Any questions for me on that one?